It's always our favorite time of the week, right? All right, so welcome to this session, Quarkus Deep Dive. So we'll do I'm guessing about 45 minutes-ish introduction on Quarkus. For those who don't know it yet, we'll go into a little bit of details on performance and stuff like that. And then after that, it's going to be up to you, hands-on, to explore Quarkus, and we're going to go and explore a little bit how to get started, and then how to build a cloud-native application and expose some stuff and everything. But we'll look at that in a minute. So just so I know, who's already worked with Quarkus? Okay, so we have about 5 hands. Okay, and so the rest, you've maybe heard of Quarkus. You're curious what it's all about. And so, yeah, let's jump into that.
The all-important Wi-Fi password was up there, and it's down here. You would think that they would make it nice and easy to remember, but no.
Okay, so just a quick introduction on us. So I'm Kevin. I'm a developer advocate at Red Hat, and, well, so is Eric, but we'll see it in his slide in just a little bit. So you can also, if you have questions, I speak French. Eric? Un tout petit peu. Yeah. Excellent.
That's about as much.
Great. Yeah, and so I'm from Belgium, so I'm not a native French speaker, but I do speak some French. Well, and then I don't know if you want to. I think it's recorded.
Is it recorded? Okay.
Yeah.
So my name is Eric Deandrea. As you can tell, I don't speak much French, and I'm not from Europe. I'm from the US. I'm pretty well adjusted to the time because I've been in Europe for a week or so already. I spent the last week in Barcelona, so good to be here and meet everybody.
Say Barcelona, right?
Barcelona?
Barcelona. I'm just kidding. All right, let's get into it. So, before we actually get started with the session, just some advertisement on some other sessions by us that you'll see us here this week. So, me tomorrow, I'm talking about Camel and Camel Quarkus and serverless Camel Quarkus. So, integration between different components using the Camel framework. Then Eric.
Yeah, I'm doing a talk tomorrow about microservices testing and everything that goes horribly wrong that they don't tell you about when you read the microservices manual. That's tomorrow evening, I think. And then I have a talk about anybody using Spring. Nobody's using one Spring? Wow, that's a very different audience than what I'm used to. So I have a talk about looking at Quarkus through the lens of someone who's familiar with Spring on Wednesday.
And then on Wednesday as well, I'm doing a session, completely kind of a different realm. It's about delivery of the application. So we're going to talk about progressive delivery. So you know probably CI/CD. So we're going to take it to the next level with progressive delivery, where we're going to look at automatically rolling out features, but gradually. So, like a little bit at a time, looking at metrics to see if everything goes well. Then we'll roll it out further and everything. So anyway, that's the session I'll talk about on Wednesday as well. Enough advertisement about our sessions. Well, I guess one more.
Yeah, and so we're going to do a book giveaway on Wednesday as well down at the Red Hat. I think it's down. I don't exactly know where the booths are, but at the Red Hat booth on Wednesday afternoon, we're going to do a book signing and a giveaway for anybody who's interested. There's only a limited number of copies, unfortunately. So not everybody's a winner, but it's for free. You can download it.
Excellent. All right, let's talk about traditional Java. So traditional Java is designed for throughput at the expense of footprint, right? So if you think of a traditional Java application, your Java EE, or even more classic Spring applications, on the JVM, they're really designed to be long-running with high throughput, and the idea is not necessarily to be deploying the applications very often. So the footprint's not necessarily that important because you put it on usually kind of nice and beefy systems, virtual machines, and then if you need more resources, you'll add more RAM and more CPU or whatever. The operations people will take care of that. But that's how you would scale those applications in the traditional world, right? And so they were designed to be long running at the expense of startup speed. So, you know, your traditional Java applications, they don't start up very fast, right? I mean, I don't know in your experience, but my experience in the past, starting up a Java application would take, you know, definitely seconds, if not minutes, you know, to really warm up and start. So, but that's not so great for containerized applications, right? Traditional Java applications, they're built for rich dynamic behavior, built for mutable systems where, you know, you have dynamic behaviors, you have these servers, and, you know, you have an application server like a JBoss EAP or WebLogic or something, which has a lot of dynamic components. And so you can work and deploy those in a more dynamic way. But containers are by, you know, kind of by design immutable, right? So if you start a new container, it's going to start up its stuff. If you make some changes in your container, they're not persisted, right? So if you start up another container, especially in the world of Kubernetes, your container might, you know, be placed on a different node, or multiple instances will start up. And if you make a change in one container, that's not going to persist. That's not going to be there in the other container, right? So you need a different way of working with your Java applications that's a lot less dynamic. But of course, you have the advantage of being able to scale more easily and orchestrate and everything. So there's some advantages to using Kubernetes, but the traditional Java applications weren't necessarily built with that in mind, right? They were built in mind of having, you know, kind of the big virtual machines with application servers on them and everything. So it's a different world. And so, you know, if we think about scaling on Kubernetes, a traditional Java application, let's say, hey, we're getting more load on our system, more requests, we need to scale up, we need to create more containers. Well, it takes some time with a traditional Java application because it needs time to start up. And then even once it's started up, it needs to, you know, still do some optimization to really reach, you know, the point where it takes, where it can accept enough requests to be fully ready and to meet, you know, let's say your service, your SLA, your service level agreement. And so a traditional Java application, the way that it starts is you do your packaging, you know, or your Maven package or your Gradle or whatever. And then once it starts up, you know, it'll do, you know, loading config files and class path scanning, building its kind of model of the world. But it does all that after it actually starts up. So in the world of containers, your container has already started up, but your application is actually not ready to receive requests yet. So that time, you know, it's kind of sitting in limbo. So if you want to scale up fast, well, you can't because you're still waiting for those containers to be able to, you know, catch up. And in the meanwhile, if you have a lot of requests that are coming in, you may kind of lose those requests. So that's not so ideal. So the way, and so if you look at a node on a Kubernetes cluster, you know, you have your traditional Java applications, you know, typically quite large. And so you'll see, you know, you can place a few of those applications on a Kubernetes cluster, for example, on a server in the cloud. But you'll see here, actually, that fifth instance of your application can't be scheduled on this node, even though there's space, right? You see the black kind of space around our applications. But because of the size, it can be scheduled on this node. So you'll see that, you know, Kubernetes will try to restart this and say, well, there's not enough resources. But it'll try to schedule it on a different node. But, you know, if you don't have enough resources, well, you can have 4 instances. So you can't scale very well and very granularly. And so what happened is that, you know, in the cloud world, what a lot of organizations would do is, yeah, we have our traditional Java applications. We're not going to touch them because they work or whatever. But then for everything else, we'll use non-Java runtimes because they have a smaller footprint. They start up faster. So, you know, think maybe a Node.js or a Python or something. And so you'll see our traditional Java applications get scheduled. But then, you know, all those new kind of services, all those new applications are going to use a different runtime, which means that, you know, if we want to work with those different languages, that means we need to learn new languages. We need to learn the new ecosystem. And you know, most of the time, actually what we'll see is that, Java has a very rich ecosystem, a lot of optimizations and everything, and we can't take advantage of those. Now we need to train ourselves with something different, which is not so ideal, of course. So what about our existing Java skills that we've built up over the years? I mean, they're pretty good for, I think, for all of you as well. And so that's where the Quarkus project, kind of comes in as, to try to address those issues with the traditional Java world where instead of, big applications that take a long time to start up, that use a lot of memory and have a big footprint, we'll try to, make Java more cloud native, more, interesting to use with the cloud native world. And we see our little friend Duke, the Java mascot, he's pretty happy with Quarkus as well. So the way that Quarkus works, so at the top you see, the traditional Java build style, and at the bottom you see how Quarkus does it. So you'll see that instead of, just doing the packaging and then loading everything dynamically after it starts up, Quarkus will try to do a lot of that stuff during the build time, which means that it needs to do that once. And then, as you deploy it in containers, all that work is already done, so it can start up a lot faster. So all that class path scanning and all that optimization and building its model of the world happens before it's actually packaged, which makes it, smaller and a lot faster to start up.
So even things like bean injection. So like if you're familiar with Spring or other dependency injection frameworks, if you were to actually debug your bytecode and look at an injection point at runtime, it's actually not the actual thing you would think it is. It's some JDK dynamic proxy that you have to step through 5 calls within the call stack to find. Quarkus does that bean injection right at build time. So when you get to runtime, you don't have to do that. And kind of going back to that warm-up slide that you had too. So the just-in-time compiler is really, really good at what it does. And so Quarkus can actually pre-warm the just-in-time compiler at build time so that it can shorten that curve.
Well said, well said. And so you have, of course, Quarkus works on, our traditional JVM, but you can also do native compilation, of course, with Java, just like you can with, Spring 3. I don't know if you can kind of do it with Spring 2, I guess.
Yeah, not supported.
Okay. Who here is familiar with GraalVM, native compilation of Java applications? Okay, so basically in a native compilation of your Java application, you would use GraalVM to do a native build of your Java application, which means that you don't need a JVM. It gets compiled down to a binary, for example, for Linux. And so it starts up a lot faster, is even smaller, but you completely use the dynamic behavior. So I don't know if you have anything.
Yeah, I mean, everything in technology is cyclical, right? 20 years ago, we were building native executables that we were running on a target platform, and then Java was invented to solve that problem, and here we are building Java apps and eliminating the JVM and going back to building target architectures. But the key differentiator here is that, and I don't like to diminish this a little at all, but it's almost like a side effect of the design in the first place, to be able to do native image, and Quarkus has been able to do this since almost 4 years now at this point.
Yep, and so here, of course, we need to prove it by, showing some some graphs and some numbers. So here you see, for example, a traditional cloud-native stack. I think it was a Spring Boot application in this case that uses, a fairly small application, but it still uses 136 megs of memory in this case. The exact same application, but built with Quarkus on the JVM. You see in the second example here. Uses already almost half of the memory footprint. And then if you compile it down to that native binary that we're talking about with GraalVM, you see it's a much smaller footprint. So in this case, only 12 megs. And then in terms of startup time, you also see the difference between our traditional cloud native Java application that starts up in 4.3 seconds, which if you think about. If you go to a website and you need to wait 4 seconds, that feels a little laggy, right? It's like 1, 2, 3, 4. That's not very responsive. So you can see with the same application built with Quarkus, on the JVM is already using less than a second, and then definitely if you use a native binary, it goes really fast, right? It starts up pretty much instantly. I mean, it also depends a little bit on the dependencies that you're using, of course, but in this case, it starts up very, very
I don't know
fast.
if you have this slide later, but one thing this slide doesn't show is throughput. So it's one thing to like use half the amount of memory. You do have the slide?
Maybe it's, let's see. No,
All right.
it's going to come.
It's gonna come. All right, hold that comment.
All right.
Someone
And so,
got a question.
oh, sorry, yes.
What are the limitations that you have to kind of put in to have such a small native build? How they can
So limitations for native compilation or just in general with JVM as well?
the ground VM and the OpenJDK, for example. I mean, not all of them, but what
Yeah.
are kind of the big ones that you can't have in a native application using ground VM?
Yeah, I'll touch on a few here, and I think you've got the slide which shows in a few, but a couple of them, when you build native image, so when you remove the JVM, you kind of have to take what they call a closed world approach. You kind of have to know about your runtime environment. So the days of like, you're going to deploy your app into a dev environment, you turn off security completely, because that's what every developer does, right? You don't have any security on your laptops or in your low environment, or you work with MySQL or Postgres, but then when you go to production, you work with SQL Server or Oracle or whatever. You kind of have to know what you're going to do and when you're going to do it. If you're doing any kind of reflection in your code, or if any of the libraries that you use or depend on do things with reflection, you have to know about it, and you have to tell the GraalVM compiler about it, because GraalVM will eliminate all dead code that doesn't have a static compilation path to it. So those are kind of some of the key things. Does it mean that, hey, I'm using this third-party library and it doesn't work, that I can't use it? No, it just means there might be some more work that you've got to do, and it's not fun,
Yeah.
unfortunately. And it's not just a Quarkus thing, it's just the way GraalVM works.
Yeah.
And I think you've got some more stuff on a slide upcoming.
I think so. Yeah,
Yeah,
we'll
the
see.
one with
what-
the little
what we put
weird
in the
chart.
slides. Yeah, I forgot what I was gonna say.
Move on.
Okay, we'll move on. So here we see that same node, in this case, we're gonna use Quarkus, and so you'll see that we can actually use Java for cloud-native applications with a small footprint, with a lot of density on our servers to use them in the most optimal way, which is, kind of financially interesting. It's interesting in terms of resources. It's interesting in terms of scaling very dynamically based on the requests that are coming in at the moment, and generally being able to optimize everything. So we can use our existing Java skills and not throw them out the window for some other language. We can actually continue to use Java. And actually, you see here that Quarkus is smaller than some other non-Java runtime, so you can actually even have some performance and some resource optimization using Quarkus. So here's that warm-up time.
The warm-up
here's
time
your-
slide, yeah.
Yeah.
So if you're interested in what the JVM does, there's a link at the bottom. I think we'll share the slides somehow. I'll always put them out on my speaker deck. But there's a talk by Simon Ritter from Azul Systems that if you want to get nitty-gritty, if you watch the first 13 minutes of his talk, I'm not going to do it justice in the next 1 or 2 minutes. But essentially, the startup time is one thing, but then actually optimizing your application to meet its max SLA is a completely different thing. And the just-in-time compiler within the JVM is really good at doing that. And depending on the application, that period of warm-up time could take minutes or even an hour or two based on what the application does. And then the just-in-time compiler will re-optimize the bytecode at runtime to optimize for whatever the application is doing. And what Quarkus does is it kind of flips that on its head. It can do a lot of that stuff at build time and then just kind of hand the just-in-time compiler stuff that's already been done and kind of pre-warmed for it. You want me to take that? Yeah, and what was kind of interesting is we actually, I'm going to say we a lot, and I have absolutely nothing to do with it. So I'll just take credit for it as the speaker sitting up here on the podium. But We actually did looked at, well, what's not just the cost impact, but the carbon footprint of a couple different Java frameworks, because everybody wants to be carbon neutral and green friendly and whatnot. What impact does the framework play? And we actually found that running this on Amazon for a period of 20 days, where we funneled requests at these applications, indefinitely, we found that we could get the same throughput on a T2 micro that a Spring app took on a T2 medium, and that we could shrink the carbon footprint by 2 to 3 times. Now, how you measure carbon footprint, I have absolutely no idea. There's a link to a study up there that it's pretty complicated. It's more than just like measuring the amount of electricity that a server takes. It's taking into account the build process of the frameworks and all that kind of stuff. But it was done with lab coats and in a clean room and whatnot. But it was pretty interesting. And I know we talked about too, like the density and the memory footprint, but you also kind of have to think about throughput as well. So if a Quarkus application uses half the amount of memory, what we found in a benchmark is that, well, that same application that's using half the amount of memory can service 4 times the amount of requests. So not only have you shrunk the memory of one instance in half, you've also reduced by a power of 4 the number of instances you need to run an application. So what's that math, 8? I don't know, it's 9 o'clock on a Monday and I'm a little jet lagged, so I can't do that math. Power of 8?
Sure. I don't know if you've seen this study too that compares the different programming languages and their footprint on the
How efficient or memory, how carbon efficient a particular language is. There's a link to it from that study, and it lists all the different programming languages and how carbon efficient or how efficient they are and I was actually surprised when I saw Java up near the top. Something like Python is awful. Like Python is really awful from an electricity usage.
Yeah. It's like 73 times less energy efficient than Java, which is pretty surprising, right? Node.js was like 4 or 5 times less efficient than Java, so we're good for the environment as Java developers. So, all right. So another really cool thing about because we're talking about using Quarkus to optimize our footprint and having fastest startup time and everything, which is all great for our organization and optimization. Our operations teams are happy with that. But my favorite thing about Quarkus is the developer joy part. So there's a lot of work that goes into Quarkus to make working with Java and Quarkus a lot more fun. The traditional way of developing with Java, where you have to kind of recompile and redeploy to see your changes, and then you make a change and you need to recompile, blah, blah, blah. So that's something that with Quarkus, out of the box, if you start Quarkus in this dev mode, which you can run on your local machine typically, it'll reload automatically the changes that you're making. So when you hit refresh in your browser or whatever you're testing, it'll automatically reload your changes, which makes it a lot more enjoyable to work with Java. It has this concept of dev services, which you'll also explore in the hands-on lab, where, for example, if you're using, let's say, a Postgres database, which is exactly what we'll see in the lab. Let's say that I'm using, that my organization uses Postgres, and they're using also some MongoDB, and they're using another database, or they're using a Kafka or something. Well, if I'm doing local development, I either need to connect to some database that's running somewhere, which isn't so ideal, because then you're sharing these resources, and if you're doing local development, might not be so not so ideal. So Quarkus has this concept of dev services based on test containers. So who's familiar with test containers, by the way? So a few people. So what's really cool about test containers is that you can start up those kinds of dependent services, such as databases and everything, in a container, and so you can have them pre-configured. And so test containers, the idea is that as you're running your test, it'll spin up a container, let's say a Postgres database, that's linked to your test. So it'll run your tests, start up that container, do its work, and then tear that down, which is interesting because you can make much more reproducible tests, right? So if you're running in a CI environment or on your local machine, it's very handy. But Quarkus kind of takes that concept also in your local development. So for example, if I'm starting an application and I want to use a Postgres database, but I don't have one running on my local machine, I don't have it configured, Quarkus will see, hey, you have this dependency on a database, but you don't have one running. So what Quarkus will do is it'll use test containers to start up a container for you with that database configured. If you have anything in your application properties, it'll try to wire that. If not, it'll just set some default values, which makes it a lot more fun to work on a local machine, where you don't have to figure out how do I configure and start up a database, or Lord forbid a Kafka cluster on my local machine. So it kind of does that pre-configured and pre-auto-wired. There's a lot more interesting things with Quarkus in dev mode. One is, and I think, Eric, you made that updated.
No, I asked somebody else to do it.
Oh, okay.
Because I'm not a graphic. I can draw like hand-drawn stick figures, and that's
Yeah.
about as good of an artist I am.
Nice. Well, I'm impressed anyway. But you see, the guy says, wait, so you just save it, and your code is running, and your tests reran, and it's Java. And the guy says, I know, right? Supersonic Java for the win. But so the concept of that hot reload applies to your tests as well. So as you're developing, Quarkus will notice, hey, you made a change in your code, which is related to this test. So we're actually going to rerun tests automatically as we're developing. So like the way that I used to develop was more like I'm making my changes, and then I kind of forget that I have tests. And then as I'm doing my Maven package or whatever, it's going to run the tests. And of course, they're all broken because I didn't take that into account. So with the live test mode, actually, as you're developing, is going to run those tests and give you immediate feedback as you're changing your code. So you'll play around with that in the lab as well. So that's a pretty cool one.
Yeah, and not just your entire test suite. Just it understands the relationship between your code and your tests, so it's only going to rerun the tests that are affected by a particular code change.
Yeah. So it's not going to run all your tests every time you type a character. That would be a little crazy. Yeah. So it's smart enough to figure out, hey, it's this test that it's this class that's been changed, and so we'll rerun these particular tests. And there's also a Quarkus CLI. Yes.
Quarkus will run all the tests, or just the specific test of the code?
Just the specific test. Yeah.
The first time you turn it on, it has to run all the tests just to learn the relationships. But after that, it only reruns tests that are affected. So like if I change one method over here, it's only going to run whatever tests are affected by that method.
Right. Okay, and then one more thing about Quarkus. So the traditional way of developing is imperative, where you have a statement, it's going to evaluate that statement and block the I/O as it's evaluating the statement, and is going to move on to the next one. That's kind of our traditional way of working, which is the most kind of the easiest way, in my opinion, to work. But you can, with Java, you can use reactive programming as well. So where the statements are not blocking, you have event loops. And so traditionally, let's say with a Spring Boot, what you would have to do is if you want to use reactive, you have to decide upfront before you start this application, before you start working on this application, do I want to work with reactive? Okay, then everything has to be reactive in my application. Do I want to use imperative? And then afterwards, I want to add some reactive behaviors with some event loops. Maybe I want to use, a Kafka, and I want to use some reactive behavior in there, or with databases or something. Actually, you can't necessarily do that. But so with Quarkus, you can. You can have in the same application, you can use imperative code and reactive code at the same time, which is kind of handy as well. I don't know if you have
even in the
anything
same
to-
class. So I could build like a JAX-RS endpoint. One endpoint is completely blocking JDBC, and another endpoint is completely reactive. Quarkus doesn't care. It'll
Right.
figure it out and do the right thing under the covers.
Which makes it nice, because let's say the typical developer is not super familiar with reactive programming, but if there's a use case for reactive, you can use it. If not, you can stick to the things that are more intuitive and.
Anybody think Project Loom is going to solve all problems? Never have to do reactive programming again. At least that's its promise. We'll see what happens with Java 21 when it comes out.
And then, yeah, of course, it's still Java, right? So Quarkus is Java, which means that you can use your the libraries and the like the tools that you're used to. And Quarkus really tries to stick to standards as well. So it'll base itself on standards from Jakarta EE, on microprofile, those kinds of kind of agnostic standards that are across different organizations, different providers, and everything. And you don't have necessarily like with Spring Boot, for example, you have very specific kind of annotations and ways of doing writing your Java code. So Quarkus tries to be very standard compliant with kind of the normal, let's say, Java.
Yeah. And I just want to clarify, you said Jakarta EE. Quarkus is not a Jakarta EE runtime. It borrows standards from Jakarta EE like JAX-RS and JPA and the transaction API and all that good stuff. But it in and of its own it does not intend to be a Jakarta EE compliant, full-fledged
Right,
like
it's the Jakarta EE core.
Yeah.
Basically. Yeah. Okay. Well, we already talked about the native compilation. There's just maybe one extra thing to mention about that. So typically, you would use the GraalVM project for native compilation. Red Hat, who's the main company behind Quarkus, is on the GraalVM advisory board. So there's influence into GraalVM and native compilation to work with and optimize to work with Quarkus. What's also interesting is that because GraalVM is an Oracle project, what Red Hat provides as well is a project called Mandrill, which is a subset of GraalVM, which is completely kind of I don't know if it's license free. Is that the word?
Well, GraalVM on its own is more than just for Java. It's like a polyglot compiler to compile to native image. And so what we did with Quarkus is we don't really, again, I have nothing to do with it, but we took the parts that we really only care about for Java and created a downstream distribution that we then contribute back to GraalVM to just kind of make it work for Java and improve the experience for Java. Because you can use it for like Ruby and a bunch of other technologies as well.
Right. And you're completely kind of, it's a fully open source upstream project, so there's no licensing kind of issues with that. So if you want to have like a kind of an idea of where you might want to use native versus a JVM application with OpenJDK with JIT, you can see here, in terms of if you want to have the best experience with developer joy, native is not necessarily the most enjoyable because the native compilation itself takes a little bit of time. It's that closed world assumption as well, so you need to be really careful with the reflection and all that. So if you're looking purely at developer joy, definitely go with Quarkus on the JVM. But for example, if you want the smallest memory footprint, if you want the fastest startup time, then you might want to consider native compilation for your application. So it depends really on your use case. If you really need something that starts up very, very fast, I mean, Quarkus on the JVM starts up pretty fast too. But if you want, very small footprints, very fastest startup time, then you might want to consider native compilation. But it kind of depends on your use case.
And I kind of say, like, my own personal opinion here, I'd say like 75 to 80% of use cases belong on the JVM, right? Native is not like it's like the shiny widget that's flying through outer space, kind of like Kafka was 5 or 6 years ago. Everybody was like, oh, I got to do Kafka. Well, why do you want to do Kafka? Oh, because they're doing Kafka and they're doing Kafka. I got to do Kafka too. The use cases are pretty specific, I think, to when you want to use native, low footprint, resource, it's very small resource utilization. But in the long run, if you have a long running workload, the JVM is going to far outperform the native binary. And it doesn't matter, Quarkus, Spring, Micronaut, Helidon, whatever the framework is. just because of the just-in-time compiler. Like the just-in-time compiler is really good at re-optimizing your application on the JVM. So it's going to outperform over time and give you better throughput, regardless of framework. Yeah.
How is it easier or difficult to switch between the two? Like, for example, I want to develop using the GDK, and then when I'm happy with the development, I package it as a RVM for the smaller footprint. Is it possible?
Yep, so the question was, for if anybody couldn't hear, is how easy is it to switch between the two? Can I have like one version on the JVM that runs over here and a version of native that runs over here? Absolutely, it's just a different flag when you build your application. And something I usually talk with customers about too is how to productionalize your native image builds, because Kevin alluded to it, it takes time to build a native image. So like to take a hello world application, compile it to a native binary, at least on my Mac M1, takes like a minute or so. And then it uses like 6 gigs of memory just to build one application. If you're working for an organization where you're building images for every pull request, and you're doing hundreds of pull requests a day, and you're doing it in the cloud, it's going to cost you a lot of money, right? You don't want to be building native images for every build that you do. You want to kind of be picking and choosing when and where you want to do it. But if you're going to do it, I would highly suggest making sure your tests run against the native image as well, because you'll always, I know myself, I always find things, my tests are all green when I run the tests on the JVM, but with Quarkus, I can just run like Maven verify, and it'll build the native image and actually run the native image and run the tests against that, and then I'll find like something's busted and I have to go fix it because I didn't do something right.
Yeah. And maybe just to add to that, so the dev mode, as you're developing on your local machine, you can do all of that. It's just the packaging afterwards that's going to change between the native compilation or the traditional OpenJDK that you're using. So as you're developing, you can use just a dev mode like you would typically, which is also kind of the idea. It's not that as you're developing your code, you're not going to compile to native every time to test it, right? It's something that you will do.
In your CI process.
Yeah, exactly. Typically in your CI process. And Quarkus, when you create a new project with Quarkus, it'll actually add, usually it'll add some, like an example code starter thing. It'll add a regular test and an integration test that that will actually be run for testing your native compilated article or application. And then just to show you what kind of applications you can use Quarkus for, and in short, anything. But you can see here, for example, you can create Kubernetes operators with Quarkus. So there's a development kit and SDK for that. You can create jobs, GitHub applications, traditional Java applications as well. So we're talking about like cloud native applications and natively compiled applications that start up fast. But if you want to write regular traditional Java applications, that's absolutely possible with Quarkus too, of course, because at the end of the day, it's just Java. So, if you want to create like a monolith or a modular monolith or something, that's absolutely possible with Quarkus too, of course. And then, of course, in terms of the cloud native container-based applications, that's where, of course, Quarkus is really going to shine compared to some of the other Java stacks that are out there. So if you want to build event-driven applications, reactive systems, microservices, or serverless applications where you're really going to scale based on the exact demand of that moment, where you need fast startup time to react to those kinds of events, well, you definitely want to use something like Quarkus compared to a more traditional Java application that's going to take way too long to start up, even though there's some projects out there that try to do some sort of warm up ahead of time of your Java application to then start up as you're scaling with serverless. But Quarkus makes more sense in those use cases too. I don't know if you have anything else to add?
Would anybody ever think of writing a CLI in Java before?
Good point.
Like, there's a bunch of utilities out there that are written in Quarkus. The Quarkus CLI itself is written in Quarkus. There's some Kafka, like the is it Kafka Cat? The Kafka Connect.
Yeah, there's a couple.
Yeah, there's a couple
KCAT
Kafka
and-
utilities that are written in Quarkus because it's just so fast that you can even do like tab completion and auto completion and stuff.
Right, exactly, yeah. And that's where, oftentimes you will use a native compilation to use, the CLI. For example, on Linux, you have a binary that you can just run without needing, a JVM or anything on your local machine. And then you can distribute it to, whoever's using Linux, or you can compile it for, people who use
On the other
those-
side.
Yeah, the dark side of the Apple people. Yeah, so CLI applications with Java become a lot more accessible and interesting with Quarkus as well. And then I think we're ready for some hands-on tutorial action. So I hope everybody brought their laptop, and I think we have the Wi-Fi password here. And so we have built this Quarkus tutorial where you can go through some steps to build a Quarkus application. So that's the link for the tutorial. Maybe just to show you real quick how to get started. So
You can take this, it's nothing that's going to disappear after today. So if you want to
Right.
share it with your friends and your colleagues or whatever, by all means.
So I'll just show you real quick. Maybe, is that big enough? Yeah. So basically, you're going to get started with a Quarkus application. So there'll be instructions to use Maven, or you can use the Quarkus CLI. So you can download the Quarkus CLI. I like to use the Quarkus CLI because it's really easy. So I can just do Quarkus create app, and in our tutorial, we'll give you a few parameters for for the artifact ID and whatever more. But you can just do Quarkus create app. And that'll create kind of a very basic Quarkus application. We'll add a REST endpoint and add some tests. So just to kind of show you, so it created an application in this case, which is called Code with Quarkus. So we'll see here that a Code with Quarkus was created. So if we use, for example, VS Code, I can start up this application.
And hopefully the Wi-Fi is stable enough for everybody to have Maven download the
Yeah.
whole internet.
And so what you'll see is if you just create, the very simplest Quarkus application, you get, by default use Maven. If you want to use Gradle, you can just add a Gradle flag to your Quarkus CLI, or you can use a Gradle command. In our tutorial, we're using Maven. I hope that's okay with everyone. If not, you can use Gradle as well. But you can see here a very kind of straightforward POM that it creates. So Quarkus, of course, is just a Java application. You can see that it uses a Quarkus BOM, which is kind of handy too, because as you add capabilities to your application, for example, I want to add an extension to work with that Postgres database, for example. You add a Postgres extension, and I don't add a specific version for each one of those extensions. We can just use the Quarkus BOM, which means that all our versions are kept consistent with the version of Quarkus, which means that when I upgrade to a new version of Quarkus, then all those kind of dependencies are also being updated. So by default, what we get is Quarkus Arc, which is dependency injection. In this case, if I don't specify any particular extensions, it'll add REST easy reactive, so just a reactive REST endpoint. And of course, our unit test, and rest assured for our unit test, so it'll add a little unit test as well. And then it'll add build plugins to build our Quarkus application as a regular JVM application, and even as a native application. So I could just based on this, I can say, terminal and, Maven package or Maven install, whatever you prefer. And, that'll just run our tests and, of course, start the application. So, kind of just by doing Quarkus create app, I have everything I need to, start up this application. And then if I want to use the dev mode, you can do Quarkus dev or Maven Quarkus dev, and that'll start up the dev mode. So we can see here that it'll actually start up the application on my local machine, and then started up on localhost 8080. So if we go there, we can see, wow, congratulations, you have your Quarkus application running. And we have an REST endpoint here, a greeting resource that says hello from REST Easy Reactive. So if we go to that /hello, and you can see it's using just the regular Jakarta components for JAX-RS and whatever more. So if we go to our application and we do /hello, we'll see that, of course, it says hello from REST Easy Reactive. And remember how I had that live mode? So if I change this to hello from Riviera dev, and I didn't do anything, I'm not recompiling or anything, I'm just going to go to my browser, hit refresh, and automatically it reloads, right? So that's pretty handy. And so the same with the tests too.
I bet your tests now fail.
Yeah, exactly. So now if I start my continuous tests, so I'm just going to hit R to resume. We can see, hey, your test failed because you changed your code and you didn't adjust your test. So because Quarkus supplied me with a default test which looks for hello from REST Easy Reactive. So if I change it to Riviera,
that's what all developers do anyway, right? You change your test to match reality versus write the tests and then write your code.
Yeah. Test-driven development, what's that? And so in this case, we can see that our test is passing, and it just reloaded that automatically, right? So let's say that I do change my test first and then make my code match that. So I add an exclamation point in this case. Then we can see that our test fails. And now we're going to change our code to match with our test. And then we can see that the tests are passing. So it gives me a very fast feedback loop. So that's just a very quick introduction for the things that you're going to be playing around with. So I'm going to go back to the slides, and then it's jam time for everybody else.
I threw the Wi-Fi password on there.
Nice, good call. Okay, so red.ht/Quarkus tutorial. I hope that link works. Okay, perfect. And so you'll go to, if everybody has the link. So I'll just go to this page. So you'll see welcome to the Quarkus tutorial. There's the setup part. And so if you're using VS Code, you could, for example, use the VS Code remote development extension pack. I usually don't, but if you want, you can use that. So what you'll need for the tutorial on your local machine is a Java, ideally 17, and Maven. The Graal VM you don't necessarily need. Who's here on a Windows machine? Okay.
Most everybody.
Yeah. So everything should work with Windows, but it's just slightly more complicated. So I definitely recommend if you have WSL, so the Windows Linux. What is the name of that? Windows subsystem for Linux. I recommend using that because it'll make your life a little bit easier throughout the tutorial. If you want to install everything in a kind of easy way, you can use SDKman, and then you can just install the particular version of Java. You can install a particular version of Maven and even the CLI of Quarkus, but you don't have to. The main thing that you'll need is just a Java JDK on your local machine and Maven. And a container runtime. So Docker is fine. Podman Desktop is what we prefer because it's fully open source. You don't need any kind of licensing or anything, but you can also just use Docker. And then once you have that going, then you can create the project. So you can either use Maven. So I added some parameters to set the project group and the artifact ID, and then the REST Easy Reactive extension that will be added by default anyway. Or you can use the Quarkus CLI, and that, then it's just Quarkus create app with the extension rest easy reactive, and then also the group ID and everything. And then you can try to package your application just to see that everything is working, and then we'll go through kind of running in dev mode and live testing, and then we'll add some configuration, work with database, deploy it to Kubernetes. So if you don't have a Kubernetes cluster available, I added instructions to create an OpenShift sandbox, which is a free instance of OpenShift, which is a version of Kubernetes. So you can just go there. I think you just need to create a free account for developers.redhat.com, which is, we're not going to spam you, I hope. I don't think so.
No, there's no credit card, and you deploy whatever you want there for free for 30 days.
Yeah, which
after 30 days, it'll just disappear, and you can do it again.
Yeah, and you can just recreate it. But yeah, so you can expose your endpoints, share them with your friends and everything. So it's really easy to deploy some applications to. So that's what we'll do there. And then we'll play with the dev services. For the Spring developers, we'll show you how to work with, if you have some existing Spring code and you want to move to Quarkus, there's actually some extensions that exist for Quarkus where you can use your Spring annotations so you don't have to rewrite your entire application. You can just change it to use Quarkus extensions. And that will be addressed in Eric's session tomorrow as well. Is it tomorrow? Wednesday for the Spring developers. And then after that, we'll go through some use cases with a cloud-native application. So we'll call an external REST endpoint. So we're going to create basically this REST service, which returns different types of fruit in the season that they're ripe in. And then we'll call this external REST client that's going to show kind of, I think, like the nutritional values of these fruits or something. And then we'll look at how to add fault tolerance in case that REST client goes down or something, that we handle that gracefully. We'll add health endpoints to our application. So Kubernetes looks for readiness probes and liveness probes to make sure that your application isn't just, that your container isn't just running, but your application is actually running inside and is ready to receive requests. So that's pretty easy to do with Quarkus as well. Then we're going to look at how to expose metrics from your application, and then we're going to add a little bit of security with JSON Web Token. So that's the tutorial today. And so, yeah, so try it out, and we're here for any issues, questions, and we'll try to help you as much as we can.
No issues, all features.
All features. Yes, please. Any questions? All right, we're going to wrap up, but you can keep working for a little bit more, but if anybody's, wants to go,
We're going to go.
we're just going to go through a few more slides. So I don't know if you wanted to do a quick Quarkus 3.
Yeah, what am I looking at here? Oh,
Quarkus
yeah.
3.
Yeah, so Quarkus 3 came out, when did it come out? Month or so? Month and a half or so ago. Feels like it was an eternity. Not really a huge big bang release, but just a lot of upgrades to a lot of the core stuff under the covers. So like Hibernate 6.2, which that in and of itself, if you're doing JPA Hibernate, was kind of a little bumpy and rocky. Did some changes you had to make just with Hibernate. There's the new Dev UI. There's anybody familiar with contract testing? So with the Pact framework, if anybody is interested, I have a whole talk on that tomorrow that I'm going to do, but there's a whole new extension for that, some Azure Functions stuff, and anybody who's developing services for Kubernetes, specifically that use the Kube API, there's a new dev service. So like you've seen with Postgres in the example here, if you need to like simulate a Kube API under the covers, there's a new dev service that can do that. And then just aligning with a lot of the Jakarta standards, Microprofile 6 and Core Profile, or Jakarta EE Core Profile 10. If you've been following Quarkus at all recently, or since its inception, you know that it moves very, very fast. New releases every week with a new kind of major release or major.minor every 3 to 4 weeks-ish. But I know that starting with the current release that's there, 3.2, they're moving to an LTS or a long-term support model. I think it's a year even in the community, until the next LTS release that comes out. So that's something new with 3.2 that just came out. So, and then anybody who's looking for more help or to get started, is anybody familiar with the superheroes sample? So like the Spring has the pet clinic, we have the superheroes. I'm actually the maintainer of this project, always looking for help. If anybody's looking to get involved with Quarkus and you feel like, oh, Quarkus itself, it might be a little more daunting. If you want to get involved, there's tons of issues that are open in PRs. Like every true open source project, it only works when the community helps out. But it's a system of microservices that pretty real world, much more than hello world, and has lots of tests. So if anybody who doesn't know me, I'm a very big fan of test-driven development. I practice it not in my day job because I don't write code each and every day, but Kevin can attest, and we were just chatting up here about how, like, even when I build workshops, everything is automated and whatnot. So there's a whole bunch of good stuff there. And there's always lots of different customer stories that are out there. So anybody who you need, you've got to convince your boss or whatever that, hey, we should try this out. There's tons of, and this is only a very small handful of different customers who have come to blog about it without us, saying, hey, Mr. Customer, or Mr. Customer, would you like to come blog about it? They just take it on their own to come talk about it.
Right. Yeah, I mean, Quarkus is definitely used in production by major organizations already. So, like, if you want to try to convince your organization to switch to Quarkus and they say, well, it's not mature enough or something, well, there's lots of organizations that are using it successfully in production. So it's definitely, stable enough.
Yeah, I was talking with Kevin. I was at a conference in Barcelona last week, and I was talking with some developers from Lufthansa, and they were saying that they've actually got an initiative to get off of Spring completely by the end of the year, and they've got a whole internal training program where they're teaching their own developers how to build Quarkus apps and how to convert apps from Spring to Quarkus.
And then, if you're looking for more resources, so we already shared Eric's book, Quarkus for Spring developers. There's also another free book that my colleagues wrote. Well, it's not a free book. We offer it for free through the developers.redout.com. This is how to modernize a legacy application to kind of more cloud native application, also using Quarkus. So you can download that for free with this link. I'll give you a moment. I see some people taking pictures.
We'll put these slides on our speaker deck and tweet them out and whatnot.
Right. Yeah, I'll post everything on our Twitter. Oh, it's lunchtime. I get a notification. Yeah. And and there's actually more books available. So if you just go to developers.redout.com, where you signed up potentially for that OpenShift sandbox. So you have a bunch of tutorials, articles that Eric writes, that I write, that our colleagues write. So a bunch of books that are available there. So lots of resources. So definitely take a look at that, free. And then if you had a good time, let us know. We're on Twitter or LinkedIn or whatever social media you use.
There's way too many of them.
Yeah. And we'll definitely post the link to the slides on Twitter and then maybe LinkedIn. And I think that's it. Yeah, there's just a link for the sandbox. Reminder for the upcoming sessions that we'll be in. And that's it. So thank you. If you want to keep working on this tutorial, feel free. In any case, you have the link. All those resources, you can work on it anytime you want. And if you have any questions, just ping me. Again, Twitter, LinkedIn, whatever. If you can find my email, you can email me. But yeah, if you have any questions, definitely let me know. And also, any kind of feedback you have, good or bad, let us know. You can come talk to us after the session. And if you saw issues with the tutorial itself, in the top right, there was this edit page, so you can go to our GitHub and create issues, or even better, you can create pull requests yourself to make the tutorial better. And with that, any further?
No, that's it.
Okay. Well,
we'll be
then,
here
thank
all
you.
week.
Yeah, we'll be here.